When an object sits on an inclined plane, part of its weight tries to make it slide down the plane, and the other part of its weight causes it to press onto the plane. In other words, its weight has two components, one parallel to the plane, making it slide down, and one at right angles to the plane, making it press against the surface. For equilibrium there would need to be two other forces present, the normal reaction force of the surface pressing on the object, and a force acting up the slope to prevent the object sliding down. This may be due to friction or to some other source. If we know the weight W and the angle theta, finding the components is easy. The components will be W sine theta and W cos theta, because these are what components always are. The tricky part is getting the sine theta and the cos theta the right way round, and knowing which one's the component parallel to the slope and which one's the component perpendicular to the slope. We should really find the components by drawing a vector diagram and resolving, but there is an easier way. Imagine what would happen if theta, the angle of the slope, was 0. The weight would act completely at right angles to the surface, with no component parallel to the surface. If theta increases a little from 0 so that we have a small slope angle, we would expect to have a small component of the weight acting parallel to the slope and a large component acting at right angles to the slope. If theta is increased further, it makes sense that the component of the weight acting parallel to the slope increases and the component of the weight at right angles to the slope decreases. By this stage almost the entire weight is acting parallel to the slope, with only a small component at right angles, with predictable results. So the component of weight parallel to the slope is 0 when theta is 0, small when theta is small, and it increases as theta increases towards 90 degrees. The component parallel to the slope must therefore be given by W sine theta, because the sine of 0 is 0, and as theta increases towards 90 degrees, the sine theta increases towards 1. The component perpendicular to the slope has its maximum value when theta is 0, and as theta increases, this component reduces. That's why it's given by the formula W cos theta.